Hey guys, today we'll be talking to you guys about the preparation of ethers and epoxides from alcohol. For preparation of ethers, we'll go over Williamson ether synthesis. For synthesis of oxiranes or epoxides, we'll talk about how Williamson ether synthesis can be done with halohydrins to produce oxiranes. Oxiranes are similar to ethers, but they are cyclic ethers of any size. Epoxides are specifically three-membered rings.
Williamson ether synthesis can be done with both cyclic and acyclic molecules. It is an SN2 of an alkoxide with either an unhindered alkyl halide, alkyl sulfonate or alkyl sulfate. This diagram shows the general reaction for Williamson ether synthesis. The leaving group in the reaction depends on what the alkoxide was reacted with. An alkoxide nucleophile can be made by adding a reactive metal, such as sodium or potassium, or a sodium hydride like NaH to an alcohol.
The reagents needed to make this reaction happen are most commonly Na and something like CH3CH2CH2Br. The CH3CH2CH2Br part will vary depending on the chain you want to add. For the reagents in this reaction you need a base. So in this case our base is the NaH. Here is an example. In this example there is the NaH and then the Br with the chain that is going to be added where the attack takes place at the OH. When the deprotonation takes place, the H from NaH will take the H+ from the alcohol to make it a better nucleophile.
Before the Williamson ether synthesis can take place, the hydrogen on the alcohol of the alkoxide attacks the hydrogen on the NaH reagent. The alcohol loses a hydrogen and becomes very reactive. Next, the electrons from the negatively charged oxygen atom attack the carbon that is bonded to the chlorine in the electrophile. This electron movement connects the oxygen and the carbon, and the chlorine leaves. Then, the chloride forms a salt with the sodium. This reaction can happen with both cyclic and acyclic molecules. In acyclic molecules, the nucleophile and electrophile are separate molecules, whereas in cyclic molecules, the nucleophile and electrophile are two parts of the same molecule, as seen in the diagram.
Epoxides or oxiranes can be made by a similar mechanism from halohydrins. A halohydrin is a functional group where a halogen and a hydroxyl are connected by adjacent carbon atoms. For this mechanism, the halohydrin is the starting material. A hydroxyl attacks the hydrogen in the hydroxyl group of the halohydrin.
Once the hydrogen leaves, the oxygen on the halohydrin is very reactive. It then attacks the carbon attached to the bromine and the bromine leaves. The result is a cyclic ether with a 3-atom ring or an oxirane. While forming an ether can be inter- or intramolecular, this reaction to form epoxides is intramolecular.
Thanks for watching our video.